Continuing our work with solving word problems using systems of equations, we have here that the admission fee at a local zoo is $1.50 for children and $3 for adults. On a certain day, 2,400 people enter the zoo and $4,500 is collected. How many children and how many adults attended? So we're being asked to find how many children and how many adults attended, which means that we can let C be the number of children that attended. And then we're going to let A be the number of adults that attended. And again, notice that we are going to define our variables in detail. Now, because we've defined using the two variables, then we know we're looking for two equations. And probably the easiest equation here for us compute first or to set up first involves the total number of people that came to the zoo. And there were 2,400 people total. So that tells us that the number of adults that attended added to the number of children that attended that day has to add up to 2,400. So that's our total, isn't it? Now, to help us set up the second equation, I've gone ahead and brought in this table. You may recall that we used a similar table back in Chapter 2. The type of tickets that we're selling here are that we have adult, and we're calling that we're representing the number of adult tickets sold that day by A, right? Because those are the number of adults who attended. And we have children. These are the people going to the zoo. And we're representing the number of children with C. The value of each adult ticket is $3, and the value of each child ticket is $1.50. So I'm going to put 1.5. And then the total value then that we collected, or that the zoo collected that day in adult tickets sold, is found by multiplying the number times the value, so 3A. And then the total value that was collected in child tickets is also found by multiplying 1.5 times C. And we know we were given that total value collected was $4,500. So $4,500 goes here. And then in this last column, we've got our second equation, which I'm going to put over here in my t-table because I've already decided that I'm going to use substitution method. And why did I decide that? Because I like this first equation. It looks pretty easy for me to solve that for one of the variables. So now I get to choose which variable shall I solve for, and I think I'm going to solve for A. So we've got A equals 2,400 minus C. And I'm going to take that expression here on the right hand side, and I'm going to bring this over here to my second equation. I'm going to substitute it in where that A is. So I have 3, then I'm going to put a parentheses and substitute the 2,400 minus C to the rest of the equation. So on the right hand side, I now get to do some distributive property with the 3. So we get 7,200 minus 3C plus 1.5C equals 4,500. And I've got some like terms here. So I get 7,200 minus 1.5C equals 4,500. And I'm not too concerned there about this negative 1.5 because I can see ahead that I'm going to have to subtract this negative 7,200 from the 4,500, and that's going to give me a negative answer. It's going to give me a negative 2,700 there. So that means that in this next step, when I divide by negative 1.5 to isolate the C, then those two negative symbols are going to give us a positive, which is a good thing because C, as you recall, represents the number of children who attended. So there were 1,800 children who attended that day. And so now we're going to bring this back over here to the left-hand side. It's going to allow us to solve for our number of adults. It looks like we had 600 adults. So before we take that as final answer, I'm going to come over here and check it in my table. So we think there were 600 adults, and we think that there were 1,800 children. And I'm going to multiply the number times the value. Dollars collected for adults was 1,800, and then I'm going to multiply the 1,800 times 1.5 here in this row, and I know that's 2,700, and when I add these together, there's my $4,500 that I should have gotten. So this is my check. It definitely checks. So here's our conclusion statement. There were 600 adults and 1,800 children at the zoo in attendance that day.